Hey guys, this is Mr. H. This is question number 28 from the August 2026 Algebra 2. This is Algebra 2. I was just looking over the exam and there were a couple questions that I thought were interesting, and this is one of them. It's basically a transformation problem. They've given you this function, and what they want you to do is they want you to transform it by doing f of x plus 3 inside the parentheses, and then, excuse me, minus 4 outside. So if you know your transformations, you know which way the horizontal shift should go. You also know which way the vertical shift should go, right? But unfortunately, a lot of students um, struggle with the transformation. So this is what I always say. You should always have a go-to function no matter what, a go-to function. I like x squared because I know what that looks like. I know it's going to be a smile. I know it starts at the origin, right? I know that. Now, so what I'm going to do, let's assume that you don't know what this transformation does. Well, make your own function and then do that transformation on your function to see what it looks like. So I'm going to do, actually, let's change this up a little bit. I'm going to make this g of x because I want it to be unique. G of x equals that. And then I'm going to go g of x plus 3 minus 4, and I'm going to see how this function gets shifted. I think that's a good test taking strategy. All right, so if you don't know exactly what the transformation is, create your own function and then do the transformation on it. So let's go. I'm going to grab the calculator. First thing I'm going to do, I'm going to go to the main calculator screen and I'm going to define my function. So I'm going to say g of x and then control right here equals, and then I'm just type in the parent function x squared, right? All right, now that's done. Now I've created a variable. Now I'm going to go graph it. So I'm going to come here. I'm going to press the variable key, and now there's my function. All I have to do is put an x inside the parentheses and then press enter. Now, it is what I thought it should be. It's a quadratic function, right? Just a very basic parent function quadratic. Now, but here's the key. Now, press tab and go get the function again that we created, we defined, and then just do what they did, x plus 3, and then minus 4 and see how it changes the function. So you can see it moved it to the left. How many? 1, 2, 3, and then it moved it down. Now, the best way to see this is we're going to do menu 62, and I'm going to first find the vertex for this one, and it's 0, 0 as it should be. And now I'm going to do the same thing, menu 62, and I'm going to find the vertex for the one that was transformed. Oops, what happened there? Didn't like that. Let's go Control Z. I didn't want that. All right, let's try that again. Menu 62. And then I click on this graph and I'm going to start over here. Right, so you can see it got moved 3 to the left and then 4 down. So now that I know that, I can come here and actually do that. So that's what I'm going to do. So I'm just going to cover this as best I can. Right. I'm just going to trace over the original. And then what I'm going to do is I'm going to make that transformation. I'm going to move everything 3 to the left. 1, 2, 3. And now I'm going to move it down 4. 1, 2, 3, 4. So, oops, 4. So that's where it should be. That's the transformation. That is the answer to this question. Again, even if I didn't know how to originally do the transformation, if I can come up with my own function and then do the transformation that they did, let me make this, you see the gx plus 3 minus 4? I'm saying if I don't know what that does, I'm just going to make that transformation and see what it does to my original. And you can see it moved it to the left 3 and down 4. So that's what I did for this one. Okay, again, in my opinion, because sometimes you forget things, sometimes you never learn things, but I like to encourage students to be test takers, smart test takers who, even if they don't know how to solve something directly, they can figure out another way to get to the same answer. I think to me, that's more impressive than just knowing how to do transformations. Being able to figure out things that you may not know, or you may have never seen, just going, oh, let me see. I can create a function. I can also do that same transformation on my function, and then from there, I can extrapolate and say it's probably going to do the same thing, in which it does. So this is the answer. That's it. Hopefully, you like this. And again, I'm all about using your calculator strategically. So I'm going to stop and post.